now we are going to optimize copying the heat at each iteration, at each time step to the host. And as you know, we were calculating the heat at the end of each loop. At the end of each time step, heat is calculated, but for performance reasons, we were just copying at the end of the program, not inside the loop, because we don't want to create time overhead. But we can maybe create another ACC queue, and in another queue copy the temporary heat to the GPU, and while the next heat is being calculated, the previous heat can be can be copied. This is the idea. Copying can start while the stencil and boundary kernels are running parallelly while inside the for loop. Therefore, we will record the heat, maybe to use the data later or to just visualize it. In order to run two queues, we need a non-blocking queues, and this is actually the idea. If we use single queue inside the loop, this copy will create additional time overhead. And what we want to do is, instead of using this single queue, creating a second queue, and copying can be done in parallel while calculation of the next heat. And yeah, this is the idea actually. We need to create another queue, non-blocking queue, and assign the task of copying the previous one, while the next one is being calculated. And I deliberately called this copy function here because it can run in parallel, but it could be called just before or after the kernel executions. And because they are non-blocking, calling position is not important. That is also an important issue. Thank you.